Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called 9-Pin Bowling by Katie Splendor and Sudoku. And here are the rules. We have normal Sudoku rules apply. That is, each row, column, and 3x3 region has to contain the digits from 1 to 9 once each. We have killer cages where digits in a cage do not repeat and must sum to the clue in the top left. So, for example, if this were, say, actually, let's use here. If this were, say, a 6, this would have to be 4, because these two digits must add up to 10, because there's a 10 in the top left corner of that killer cage. And that's an example of how killer cages work. We have entropic lines, where any 3 adjacent digits along a peach line must contain one low digit, 1, 2, or 3, one medium digit, 4, 5, and 6, and one high digit, which is 7, 8, or 9. So along these 3 adjacent digits, one must be low, 1, 2, or 3, one must be medium, 4, 5, and 6, and one must be high, 7, 8, or 9. And that's how entropic lines work. And finally, we have German whispers, where adjacent digits on a green line must have a difference of at least 5. So, for example, if this were, say, a 3 here, this would have to be 8 or 9 here, because the only digits which are 5 or more away from 3 are 8 and 9. And I will be calling them Whisper 5 lines because a setter came up with that naming convention, and I thought it made a lot of sense because it's very easily extensible. And finally, we have Kropki dots, where digits joined by a black dot have a 1:2 ratio, and not all dots are given. So, for example, if this were 2, this would have to be 1 or 4, and this would have to be 1 or 4, because these digits must be in a 1:2 ratio with each other. Anyways, those are, and not all dots are given. Those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, 3 digits adding up to 24 must be 7, 8, and 9. 3 digits adding up to 23 must be 6, 8, and 9. And 3 digits adding up to 22 has to be either 5, 8, 9 or 6, 7, 9. So we're guaranteed a 9 here either way. That means we are guaranteed a 9 in one of rows 1 and 2 here, and we're guaranteed a 9 in one of rows 1 and 2 here. Same with rows 8 and 9. We are guaranteed a 9 here. We're guaranteed a 9 here. That means the rest of rows 1 and 2 and the rest of rows 8 and 9 cannot contain a 9. So this must be either 5 or 8 or 6, 7 to add up to 13 because it cannot have a 9. This cannot be 2 9, so it's 3, 8, 4, 7, or 5, 6 here. This digit is in a 1:2 ratio with 2 other unique digits, so it can only be 2 or 4. 2 can be in a 1:2 ratio with 1 and 4. 4 can be in a 1:2 ratio with 2 and 8. So if this is 2, this would have to be a 7, 9 pair. And this would be 1 and 4 here. If this is 4, this would be 2 and 8. So these two digits would have to add up to 14. So you could have 5 and 9. This couldn't be an 8 here because if this is 4, this is a 2, 8 pair here. So then this would have to be 6 here and 8 there. Okay. That means we are guaranteed a 2 or 4 in this set of cells separated by the black Kropki dots. This is, again, 5 through 9 here. We have 5 through 9 here. Anytime, so on a Whisper 5 line, you'll always alternate between low digits and high digits on the Whisper 5 line. Because if you, and you cannot have a 5 on a Whisper 5 line, because if you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to 5, you get 10 or more, which is not a digit. So that's why 5 cannot be on a Whisper 5 line. Again, for low and high digits, you'll always alternate between low and high digits. For the low digits, 1 through 4, what digits can be next to it? 1 can be next to 6 through 9. 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can only be next to 9, all of which are high digits. So next to a low digit is guaranteed to be a high digit. And the same thing is for a high digit. What digits can be next to those high digits, which are 6 through 9? 6 can be next to 1. 7 can be next to 1 or 2. 8 can be next to 1 through 3. 9 can be next to 1 through 4, all of which are low digits. So we know these two sets have to be either both low or both high. And since this is an entropic set, we know that these digits cannot be both all low or all high, or extra low or extra high, right? Cannot be 1, 2, 3 with another 1, 2, 3. So one of these has to be a medium. So if we have a low here, or whatever set this is, these would both be low. And one of these would be low. The other one would have to be a medium digit because of the entropic rule. And so it could be 1, 2, 3 here and 4 here. And that would guarantee 9 has to be next to it on the Whisper 5 line. Or this is high digit, 7, 8, 9, with 6 next to it. Because, again, you alternate between low and high digits. These must both be high if one of them's high. But they actually have to be part of the 4, 5, 6 medium digits. So this would be 1 or 9. Which means this is 1 or 9, and this is 1 or 9, guaranteed. That eliminates 1 and 9 in the rest of the central box, so this cannot be 9 here. This can't be 1, so this must then be 2, 4, and 8 as a triplet here, which eliminates 2, 4, and 8 in the rest of the box. This can't be 8. It's 7, which eliminates 7 in the rest of the box, or in the rest of the cage. So this is 2 and 8 surrounding a 4 here. So this must again be 5 and 9, or 6 and 8, to add up to 14, which added with the 4 adds up to 18. But we can't have a 9 here because of the 1-9 pair in the box, so this can't be 9. This therefore must be 8 and 9. This 8-9 pair eliminates 8 as a possibility in this cage, so this must be a 6-7 pair here. Well, we have a guaranteed 6 in one of these cells in rows 8 and 9. We have a guaranteed 6 in one of these cells in rows 8 and 9. This cannot then be 6, 7, and 9 because we don't have a 6 available in rows 8 and 9. So this must then be 5, 8, and 9 here. Okay. This can't be 2, 4, or 8. The remaining digits in row 5 have to be 1, 3, 5, 6, 7, 9. 9 can't be here because of 9 in the 9 doesn't add up with another digit to add up to 9. If this is 1, this has to be 8. 3 goes with 6, 5 goes with 4, 6 goes with 3, 7 goes with 2. But we know this cannot be 1 and 8 to add up to 9 because we have a guaranteed 8 in columns 1 and 2 here, and a guaranteed 8 in columns 1 and 2 here. So this cannot be 8, which means this can't be 1 here. These must add up to 10. 5 can't be here because 5 and 5 add up to 10, and that would be a duplicate in that column, or in the cage. 1 and 9 can be with 1 and 9 here. 3 and 7 can be with 3 and 7 here. 6 can be with 4 here. But this cannot have a 1 or a 9. 7 eliminates 7 here. So it cannot be 4 and 7. It's 3, 8, or it's 5, 6 here. This cannot be 1 and 9 because we have a guaranteed 9 in these cells in columns 8 and 9, and we have a guaranteed 9 in these cells in column 8 and 9. So this cannot be 1 and 9. It's either 3, 7, or 4, 6. Similarly, this can't be 9. This can't be 9. Okay. Remaining digits of the central box are 3, 5, and 6. Therefore, this must have this can't be 6 because of a 6, 7 pair in the column. Remaining digits in this lower central box are 1 through 5. So this cannot be 5 here because 5 can't be on a whisper 5 line. 1 through 4 can only be 5 or more away from 9. So this must be 9 here. Therefore, this is 1 through 4 here. This is 1 through 4 here. And this digit for the entropic line must be a high digit and cannot be 6, 8, and 9. That forces this to be 7 here. 9 eliminates 9 here, so that's 1. So this must be 6, 7, 8, or 9 here, and 6, 7, 8, or 9 here, which leaves a low digit here. So that's 1, 2, or 3. We have 7 here. That means this can't be 7 here. 3 is guaranteed to be one of these two digits. So this cannot be 3, which means this can't be 7 there. 1 can't be here because of 1 in the column. 7 can't be here because of 7 in the column. One of these digits is 6 or 8. This digit is 6, 8, or 9. This digit is 8 or 9. So we have essentially 3 cells requiring 6, 8, and 9. That eliminates 6, 8, and 9 for the rest of the column. This can't be 6, 8, or 9. It has to be 2, which makes this 8. This can't be 4 here, no 2 here because of 2 in the column. So we know 4 in column 4 cannot be any of these digits. So it has to be one of these 2 here, which means this can't be 4 here. So this is a low digit. This must be the medium digit then, and it has to be 4, which means it can't be 4 and 6. So that's 7 and 3 there. That eliminates 3 and 7 in the rest of the box. 3 eliminates 3 in the rest of the row, so this can't be 6 here. 4 eliminates 4 here, so this can't be 4, which means this can't be 5. 7 eliminates 7 here. Okay, 7 eliminates 7 here. So if this is 6, 7, and 9, this would have to be a 7, so this can't be 6. This is 4. This is 1. What are these? Remaining digits in column 6 must be 1 through 5. We have a guaranteed 4 in one of these digits. 1 and 3 could add up 2, 12 with 8. 1, 5 adds up with 6. 2, 3 would have to be 7, but that doesn't work because of 7 in the box. 2, 5 would have to have a 5 there. So 2 cannot work here. 3 and 5 would guarantee this is 4, and this cannot be 4. So this cannot be 3 or 5 here. If we have 4 here, that would force this to be 3 and this to be 5. That could work there, though. So this is 1 or 4 here. Okay. Hmm. Hmm. Remaining digits of row 7, we have 1 through 6. 6 cannot be here because of 6, 8, 9 triplet in the box. So 6 has to be one of these 3 digits. 3 can't be here because of 3 in the column. Remaining digits in box 9 are 1 through 5. Obviously no 3 there, no 4 here. 9 eliminates 9 here, so this is 8, which makes this not 8. That's 9, which makes this not 9, so that's 8. So this must be 4, 6, and 8 to add up to 18. That eliminates 6 from here, so this 3, 5 pair here in row 4 eliminates 3 and 5 in the rest of the row. So it cannot be 5 here. So we can no longer have 4, 3, and 5 here adding up to 12. So this is guaranteed to be a 1. So it's 1, 3, 8 or 1, 5, 6 here. That eliminates 1 also in the rest of the column. Remaining digits of row 6. We have 1, 2, 3, and 5. And these can't be 3 because of 3 in the box. Where is the 9 in this right central box? Again, 9 cannot be here because we have a guaranteed 9 in this cage here and a guaranteed 9 in this cage here, which eliminates 9 from the rest of those columns. So 9 has to be here, which means this cannot be 9. Where is 9 in column 3? Same problem. These can't be 9 because we have a guaranteed 9 here. These can't be 9 because of a guaranteed 9 here. This 9 eliminates 9 from being here. So that leaves this as a 9. So this is 9 here. On the entropic line, this can no longer be 8 or 9 because we already have a high digit in these set of 3 digits. So this must be 6. This cannot be 5 and 6 then. This is 3, 8 as a pair, which eliminates 3 and 8 in the rest of the column. And box, so there's no 3 here. This is 4, 5 as a pair, which eliminates 4, 5 in the rest of the box. Okay. This is 3, 5 as a pair. Okay. Remaining digits in row 4 are 2, 4, 6, 8. Huh. Interesting. 8 cannot be here because of 8 in the box. 4 can't be here because of 4 in the box. So we're guaranteed a 4 in one of these two cells. The other digit here must be 2 or 6. And this cage has a 2 or 6 here. That eliminates 2 and 6 in the rest of the box. So this can't be 2 and this can't be 6. So we have a guaranteed 6 in one of these 3 cells. That means the rest of column, and we have a guaranteed 6 in the cage here in one of these, in columns 1 and 2. That means this cannot be 6 in the rest. There cannot be another 6 in the rest of columns 1 and 2. So this cannot be 6, which means a 6 has to be there. Okay. One eliminates one here. This is 3 and 8 here. We have a guaranteed 8 in rows 1 and 2. It's same here. Guaranteed 8 in rows 1 and 2, which eliminates 8 in the rest of the rows 1 and 2. So this cannot be 5, 8, and 9. It must be 6, 9, and 7 to add up to 22. So this is 7, which makes this a 6, 9 pair. That eliminates 6, 9 in the rest of the column. So this can't be 6 or 9. It's 8. Therefore, this is no 8 here. This is 6, 9 as a pair, which eliminates 6 and 9 in the rest of the column. So this can't be 6. We have a 1, 2, 5 triplet in this right central box. So that eliminates 1, 2, and 5 in the rest of the box. This can't be 2, it's 8. This can't be 8, it's 6. So 1, 5, and 6 add up to 12. So this is 5, which makes this 3. This is no longer available to be 3. So this is a 1, 2 pair, which eliminates 1 and 2 in the rest of the box. So this can't be 2, it's 3. That eliminates 3 here. 5 eliminates 5 here, so this is a 2, 4 pair. That leaves the remaining digits in that box as 5, 7, and 9. 7 can't be here because of 7 in the row. And 9 cannot be in, again, rows 1 and 2 because we have a guaranteed 9 here and a guaranteed 9 here. So this can't be 9, this is 5, this can't be 5 or 9, it's 7, which makes this a 9 there. Okay. What else do we have? We have a guaranteed 2 here, because this can't be 2, which means the rest of the row cannot have a 2, so this can't be 2, it's 3 and 6. That eliminates 6 from being here. So this is an 8, 9 pair, which eliminates 8 and 9 in the rest of the column and box. So this can't be 8 or 9, it's 6. This can't be 8 or 9, it's 5. This can't be 5 or 8, it's 9, which makes this an 8 here. So 5 and 3 can't be here. Whereas 5 eliminates 5 here, so it's 4 and 5. These can't be 5 anymore. This can't be 4 or 5. It's 1 or 2. We have a 1, 2 pair in row 8, which eliminates 1, 2 in the rest of the row, so this can't be 1 or 2. It's 3. That means this can't be 3. It's 1 or 2. 9 eliminates 9 here, so it's 6 and 9. 6 eliminates 6 here, so it's 7 and 6. We have a 1, 2 pair in this lower right-hand box, so that eliminates 1 and 2 in the rest of the box. So this is not 1 or 2, it's 4, 5 as a pair, which eliminates 4 and 5 in the rest of the row. So this can't be 4, which makes this a 1, 2 pair here. 3 and 6 eliminates 6 here, so that's 2 and 4. 3 eliminates 3 here. This has to be 1, 5, and 7. And remaining digits in this lower left-hand box have to be 3, 4, and 7, but this can't be 3 or 4, so that's 7, which means this can't be 7 here. This must be a 3, 4 pair. This can't be 3 because of 3 in the column, so this is 4, which makes this 3. 4 eliminates 4 here, so it's 2 and 4. 2 eliminates 2 here, so it's 1 and 2. 3 eliminates 3 here, so that's 2. Remaining digit in column 1 is a 7. We have a 1, 5 pair in this left central box, which eliminates 1 and 5 in the rest of the box. This can't be 1 or 5. It's 7. 6 eliminates 6 here, so it's 9 and 6. 9 eliminates 9 here, so it's 8 and 9. 8 eliminates 8 here, so it's 3 and 8. Okay. Remaining digits in column 2. We have 1, 5, and 3. This can't be 1 because of 1 in the row. This can't be 5 because of 5 in the row. Remaining digits of column 3 are 1, 5, and 4. No 5 here because of 5 in the row. Okay. Remaining digits of row 3 are 3, 4, 5, and 8. This cannot be 3 or 4 because of 3 or 4 in the column. This can't be 8 here or 8 here. So this can't be 3 here because of 3 in the column. We have a 4, 5 pair in column 9, which eliminates 4 and 5 in the rest of the column. So this can't be 5. It's 1 or 2. Whereas 8 in row 3, it can only be here. That leaves the remaining digits in column 7 as 1, 2, and 5. 5 can't be here. So where is the 5 in column 7? It has to be here. So since this is 5, this has to be 4. This can't be 4, 5. It's 3. 4 eliminates 4 here, so it's 5 and 4. 3 eliminates 3 here, so it's 5. 5 eliminates 5 here, so this is 1, 4 as a pair. 5 eliminates 5 here, so that's 1, which makes this 5. 1 eliminates 1 here, so that's 3. 1 eliminates 1 here, so that's 2. This can't be 1 or 2, it's 5, which makes this 1. 2 eliminates 2 here, so it's 1 and 2, which eliminates 2 here, so it's 1 and 2. Remaining digit in column 8 is a 2, which makes 4 and 2 there. 4 eliminates, well, 2 eliminates 2 here, so it's 1, which eliminates 1 here, so that's 4 and 1. And that's a solution. A little logic is necessary for this portion, but the killer cages are very restrictive. I don't know if I would consider this very easy. I mean, for me, it's very easy. But, I mean, the killer cages is fine. You have to have a decent amount of knowledge of Whisper 5 lines and entropic lines for this to work. And you have to sort of understand what it means to have a 9 guaranteed in these cells here. And you have to understand the implications of having a middle digit here. I don't know. It seems execute. Well, I don't know. I don't know how hard execution wise is either. If you, I think on the whole, I would classify this as easy because I feel like that these aren't necessarily very easy techniques, right? Um, I don't know. Maybe I'm just overestimating the difficulty here. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.